Bismillahirrahmanirrahim. Very good morning to all of you. And dear students, today I'm going to discuss topic number 1.5 or the SLO number 1.5.1 of grade 9 physics chapter number 1 measurement. The topic is about scientific notation and the SLO 1.5.1. It is talking about the calculation of scientific notation in measurement. And dear students, when we are talking about this topic, by the end of this lesson or this topic, you will be able to define a scientific notation. Sometimes it is also, we call it as standard notation. You can differentiate between ordinary and scientific notations, and you can express a given figure or number in scientific notation. So in this way, in these three ways, this topic is quite useful for you people, and it is very important in examination point of view. Dear students, when we are talking about scientific notation, as you know that one of the fascination of physicists is dealing with the very large numbers. For example, the distance between different planets, the distance between Earth and Moon, distance between Earth and Sun, or it is related to the heavenly bodies, and very small. For example, we have elementary particles such as electron, etc. So by representing, or when we are talking about many physical constants, so physical constants are also very large or very small, and therefore we are facing certain problems in calculating or in finding in measuring the quantities or physical quantities related to these things. For example, when we are talking about the speed of light, so as I have mentioned here in this slide that the speed of light is about 299792458 meter per second, and we have rounded this to three significant figures as 300000000 meter per second. Now just look here, when we are talking about this value, this figure, so here we have got 8 zeros, so it would be easy to miss one out or add another. So therefore we are just converting this into scientific notation, and in scientific notation this number is written as 3.00 multiplied 10 raised to the power 8 meter per second. So we have converted this into three significant figures. And when we are talking about very large numbers, for example, I am just sharing the example of mass of the sun with you. So when we are talking about the mass of the sun, so you can simply say that mass of the sun to four significant figure is 198900000000 and so on. Okay, so that is 1989 and 27 zeros. So these 27 zeros, it would be easy to miss one or two zeros or to add another here. So therefore we need to convert this into scientific notation, and in scientific notation we will write it as 1.989, and then we imagine moving the decimal point 30 places to the left. So when we're talking about these 27 zeros, just look at the point, yeah, the decimal point, it's just lying here. So I am just taking this zero to the left side after 1. So this means that these figures gives us 30 numbers here. So therefore I am using here 10 raised to the power 30 kg. So similar idea or similar example is applied when we're talking about very similar small numbers, sorry, such as the charge and electron. So I have mentioned the charge and electron here, it is 0.00000 and so on up to 1602 columns. So just look here, that time we have to bring we have to move this decimal point after the first non-zero digit here, which is 1. So it will be written as 1.602 multiplied 10 raised to power minus column. So because when we are counting these numbers, so it becomes 19. So there is another thing which is very important here, is that here the power of 10 is positive 30, but here it is negative 19. Why it is positive, why it is negative, let us discuss this in the next slide. When we are talking about the scientific notation, In scientific notation, a number is expressed as some power of 10 multiplied by a number between 1 and 10. So this is the definition. You can just take a screenshot of this definition. As I told you about the power of 10, why it's positive, why it's negative. So we have two rules here for scientific notation. So if the given number is multiples of 10, then the decimal point has to move to the left and the power of 10 will be positive. As I have just give an example of 6000 here. So let us assume that we have a point here after this zero, last zero. So just take it to the left. So when we are moving the decimal point from right to left, then remember one thing, that the power of the 10 will be written as positive. But if the point is moved from left to right side, then you can write it as a negative, as I have given example here. So in the same way, we have other examples here. Just look here, 49 triple zero triple zero, and when we are talking about this 7 zeros are there. So just look here, from here to after 4 it will become 8. This example positive, this example power of 10 is negative, here also positive, here it is negative. So just using these two rules, we are going to write that whether the power is positive or it is negative. So I'm going to give you some more examples here for practice. So just take a screenshot of this slide as well, and practice these, and share with me the answers of these questions in the comment section. And dear students, so this is all about scientific notation, and I hope you got enough information about scientific notation. So thank you so much for watching, and you can contact us for grade 9 assignments, past papers, and help related to the syllabus and assessment framework of Khan University Examination Board, or in bicep, or of Punjab textbooks. Okay, so this is my contact number. You can follow us on Facebook, Physics with Anwar Ali, and you can please subscribe our channel for more updates and for more videos. So thank you so much for watching. Stay tuned.